Today, we're going to pull back the curtain on the university science lab. You know, these places are amazing. They're where ideas jump off the page and into the real world. But with all that discovery comes a ton of responsibility. We're going to dive into what makes a lab session truly great, turning what could be a routine procedure into a real journey of discovery.
Right off the bat, a laboratory is not your average classroom. Not even close. It's this one-of-a-kind place where the potential for incredible aha moments lives side by side with some very real dangers. And getting your head around that duality, that's really the first step to mastering it.
So why do we even have labs? What's the big deal? Well, it all boils down to one simple phrase: learning by doing. Labs take these abstract, hard-to-imagine concepts and make them real, something you can touch and see. This is where students get their hands dirty, build actual skills, and really start thinking like scientists. It's all about sparking that curiosity.
But, and this is a huge but, all that potential for discovery has a very serious flip side. I mean, just look at this map. The scale here is absolutely staggering. Since the 18th century, we're talking over 19,000 deaths and almost 18,000 injuries from science-related incidents. Every single dot on this map is a tragedy, and it's a powerful, sobering reminder of what's at stake.
And this isn't just an abstract number. This quote tells the real story of Professor Indrajit Bazak, who died after an explosion during a demonstration. It's absolutely heartbreaking, and it's a gut-wrenching reminder that safety protocols aren't just boring rules in a book. They are a life-and-death responsibility, period.
So who is the person responsible for navigating this high-stakes world? Well, that brings us to the unsung hero of the university, the lab tutor.
You know, a great lab tutor has to wear a lot of hats. It starts with just who they are as a person. You got to be approachable. You got to know your stuff. Be fair. But their responsibilities? They're huge. They're prepping the entire session. They're the safety officer, the guide for the experiments, and the one giving the feedback that actually makes the learning stick. They're basically the conductors of a scientific orchestra.
A successful lab session doesn't just happen. It's built, piece by piece, on a solid foundation of preparation. The most important work actually happens long before a single student even walks through that door.
And that prep work really rests on these 4 pillars. First up, identification. You got to know the risks and tell the students about them. Second, prevention, using the right gear for the job. Third, supervision, keeping your eyes open and moving around the room. And finally, preparedness, knowing exactly where the fire extinguisher and the first aid kit are. It's a whole system, and it has to work together.
I love this because it's basically the visual language of the lab. It's a super clear problem and solution setup. On the left, you've got your potential hazards, the symbols for corrosive stuff, high voltage, you name it. And for every one of those problems, there's a solution on the right, the gear you need to stay safe, the right gloves, the right goggles, whatever it is. This simple pairing turns a potential danger into just another step in a controlled procedure.
Okay, so we've covered all the safety and prep work. Now for the fun part. Let's actually see what great teaching looks like in action. We're going to use a classic physics experiment as our case study, verifying Archimedes' principle of buoyancy.
So here's the core idea, first figured out way back around 246 BC. It's one of those things you might have heard of in a textbook, but in the lab, students get to prove it for themselves. The goal here is to make this ancient principle a personal discovery right here and now.
The procedure itself is actually pretty elegant, just 5 steps. First, you weigh an object in the air. Simple enough. Then, you weigh it again while it's underwater. The difference between those 2 weights? That's your buoyant force. Finally, you measure the water that got pushed out of the way and compare its weight to that force. If Archimedes was on the money, they should be a perfect match.
And here's a picture of that key moment in action. As the object gets lowered into what's called an overflow can, it pushes out a volume of water that's exactly equal to its own. Catching every single drop of that overflow is crucial if you want an accurate result. It's such a simple but really powerful way to see the principle at work.
Now this is where technique becomes so important. A successful experiment isn't just about following a recipe, it's about being precise. For instance, see that little curve in the water? That's called the meniscus. Reading the volume from the very bottom of that curve at eye level is a fundamental skill. Getting this one little thing right can be the difference between proving a scientific law and having a failed experiment. And developing that skill, that's one of the main goals.
But you know, a truly great lab is about more than just getting the steps right. A great tutor knows how to shift the whole conversation. So instead of just answering a passive question like, how do I do this? They'll flip it and ask an active one, like, what do you think is going to happen next? That simple change right there transforms a student from someone just following instructions into a real scientific thinker.
And making these big ideas click for students requires a clear game plan. It helps to start with normal, everyday language before you throw in all the technical jargon. Try framing the experiment like a little story. And one of the most powerful tricks in the book? Ask students to explain the idea back to you in their own words. That's how you know, for sure, that the learning has actually landed.
So the experiment is done, we've talked through the concepts, but how do we make sure this isn't just a fun activity they forget by next week? How do we turn the data they collected into knowledge that actually sticks?
Well, the theory behind all of this has a fancy name. It's called constructive alignment. I know it sounds super technical, but the idea itself is actually beautiful and simple. All it means is that what you want students to learn, what they actually do in the lab, and how you grade them should all link up perfectly. When those three things are in sync, that's when real, deep learning happens.
And this is absolutely crucial. The learning isn't over when the experiment ends. Feedback is where those final connections get made. It's not just about slapping a grade on a report. It's about pushing students to interpret their own results, to explain the weird surprises, and to really think about what they learned. This is what transforms a lab report from a chore into a powerful tool for discovery.
And this all brings us to one final, big idea to chew on. We've seen how a well-run lab can spark curiosity and true hands-on discovery. So what if we treated every classroom like a laboratory for learning? What if every subject was built around that same spirit of experimentation, active questions, and the shared joy of figuring things out together? Now that's an experiment worth trying.